Today, we're going to experiment with creating a synthetic data set by training different types of models, from generative adversarial networks to language models with differential privacy on the same data set. And we'll look at the effect of the synthetic data, both in terms of accuracy and privacy. Let's go ahead and jump on in. So I'll go up here inside the Gretel console right now. I'm going to go ahead and upload a healthcare file. So this is a EHR type data set. I'll add it to my EHR project that I have right now. I'm going to create synthetic data. Let's go ahead and click continue. So it will go ahead and recommend a configuration for me automatically, but what we're going to do here is experiment with a bunch of different configurations and look at some of the changes here. So here we see our default configuration. We're using a language model, LSTM, under the hood. However, there's a bunch of different configurations we can try here, and we're going to try a bunch of different variations. Starting from the default, one of the other use cases, if you have strong privacy concerns, you might be interested in running a configuration that has differential privacy. So let's see how that changes things. We can go through here and look at the model configuration here, and you can see that we've turned on differential privacy, so the DP is on. You can see the DP noise multiplier is pretty minimal, and we found this is a good setting to give you practical protections on privacy. And the clipping of the optimizer is also pretty minimal. So this is really meant to do a basic level of differential privacy applied during model training that prevents the model from memorizing anything it shouldn't. So really curious about the effect that these settings have on our privacy. Next, we'll go on and we'll try a different one here. So we'll try the high dimensionality. So this is a different type of model. Here we're using a GAN that works well for highly dimensional data sets. If you have 50, 100, 1,000 different columns, it works quite well for that. And finally, we're going to try our high accuracy configuration. Here, what we see are just some slight changes to the default configuration. Really, we're lowering the learning rate that's being used here. We're also turning off the sentence piece-based vocabulary tokenization. So this will give the model kind of as many opportunities to learn from this data as possible. So for each one of these, what we'll do is I'll go ahead and click these and we'll start training on them. Here you can see it loaded up our sample data set. What we're doing behind the scenes here is synthesizing, so essentially training the model on this data set, telling it to create another data set of the same size. We can use that to compare accuracy. It's validated the configuration here. It's firing up a worker in the Gretel cloud. You have the option of running that worker locally or in the cloud. So you don't have to wait for each one of these models to train. I went ahead and ran these already, so we can go ahead and take a look at the results. So we'll jump here into our project called EHR data. You can see our new model starting to train here. And here's the results of training on these 4 different default configurations that we have. We'll start with the default configuration. And see here, training time, 7 minutes. The quality score was a 89 out of 100. So fairly good. We say really anything over 80 is typically good for downstream machine learning use cases. Let's go ahead and do a quick survey of the other models and see how they did. Okay, so here we'll go ahead and take a look at differential privacy. Differential privacy is a hammer that you can apply to data. And so here we'll take a look at the score we got. So really, actually minimal drop here. Training time took a lot longer. That's because of the extra calculations that are required for a DP to work. But the quality score was actually pretty good. Let's go ahead and let's take a look at the report here. Privacy obviously was quite high on this, and the distributions that it learned were pretty good. We can download the detailed report, and we're going to compare this against the winner report that we have as accuracy, and you can see kind of the differences here. So I'm downloading the synthetic report. Now it's downloaded. I'll go ahead and open this, and we'll take a look at this in just a second. Let's go back and look at the other models. Going up the chain here, now we'll look at our high accuracy setting. So this is, once again, using our language model, but it's slowing down the learning rate, and we see it did quite well on the quality score, and training time was actually pretty fast on this data set as well. So this one's got quite a good accuracy. Let's go ahead and take a look at the report. So I'll download the report for that one as well. And next, let's look at our GAN model, high dimensionality data set, running on the data set. So you can see it trained quite fast, and the quality score was pretty good. So 90 out of 100 on this as well. I'll go ahead and save this report, and let's look at it as well. Give us something to look at later. Download synthetic report here. Okay, so starting at the top, let's go to our current winner, 95 out of 100, running the high accuracy model. And you can see that we generated 5,000 records. No records were duplicated in the training set. By default with Gretel, the similarity filters are on, so this will prevent any type of repeated records from being created. We have other privacy settings you can enable, including differential privacy. If you want to move all the way up, we'll look at the effects of that later. Often when I'm looking at the quality of a data set, I like to look at the pairwise correlations. You can hear the kind of the Zelda sword that would indicate that it did a pretty good job learning this data set. I also like to look at the PCA distributions. So here we can see this 2D representation of our data set, and you can see that the distributions here were quite good. Let's go ahead and compare that to what we see in differential privacy, and I think you can start to see some of the differences here. So with differential privacy turned on, you can see we got an 86 out of 100. However, our privacy protection level was very good. So you can see the different settings that we have turned on. You can see it still did a reasonably good job learning the pairwise correlations. But when we look at the principal component analysis, essentially the 2D view across all of our different fields, you start to see these different clusters or patterns emerge that don't match as closely as they did with the our high accuracy setting. Let's go ahead and take a look at this for our GAN setting as well. So the GAN also did quite well at learning the correlations. And here we see the PCA distribution is very good. And then we can look at the kind of per field distributions. I also expect to see some differences here. So let's take a look at this. So our GAN model, which was kind of in the middle of the pack on accuracy, but speed was very good. Here you can see our kind of winning model here, how good of a job it did at learning the different distributions and recreating those distributions in data. It's quite impressive. And let's take a look at our differential privacy model, which really intentionally makes it hard for the model to learn secrets in the data or memorize things like that, which gives you a lot of extra privacy settings. On some of these distributions, it did quite well, like the admission deposit. On some of these other hospital codes and things like that, you see a little bit more variation between synthetic data and the data it was trained on. It becomes particularly apparent here when you're looking at the patient ID, which is a randomly generated field. So when you're using differential privacy, it should be quite hard for the model to learn to recreate these exact patterns. So here you're looking at 3 different configurations run across the data. We encourage a lot of our customers run all of them, and just kind of seeing how the data sets work for different use cases. If you're training downstream machine learning, it's okay to use a little bit more compute. And if privacy is a major concern too, one of the really neat things is you can use differential privacy. We're not going for theoretical maximum guarantees here for privacy, so no formal like epsilon setting of less than 1. But even with small amounts of noise injected into the model during training, we get really nice quality benefits with a pretty minimal hit to accuracy.